Every person who has ever lived has faced the same wall. Not war, not disease, not poverty, death. And for most of human history, people explained death through religion, myth, or philosophy. The soul leaves the body. Consciousness moves somewhere else. Existence continues in another form. Physics tells a very different story. According to modern physics, your body is not a permanent thing. It's a temporary arrangement of particles. Your thoughts, memories, personality, fears, and sense of self all come from electrical activity inside a 3-pound organ, obeying physical laws. The atoms in your brain were here long before you were born, and they'll still exist long after you die. But that creates a terrifying question. If the matter survives, why doesn't the person? And the deeper scientists looked into time, entropy, quantum mechanics, and information theory, the stranger death became. Some discoveries seem to suggest that nothing truly disappears. Others imply consciousness may be far more fragile than humans want to believe. What makes this uncomfortable is that physics doesn't care what feels fair. It only describes what reality appears to do. And right now, reality gives us answers that are incomplete, unsettling, and sometimes deeply disturbing. Humans are very good at pretending death is distant. Most people live as if it belongs to somebody else. It happens to old people, people in hospitals, names on the news, historical figures in books. But not to us. Not yet. The brain quietly builds that illusion, because functioning normally becomes difficult if you constantly remember that your entire existence can end without warning. Physics removes that illusion almost immediately. From the perspective of modern science, there's nothing in the universe that appears protected from decay. Stars burn out, galaxies collide, black holes evaporate over unimaginable stretches of time. Even protons, which may survive longer than almost anything else in nature, could eventually decay, according to some theories. Permanence is not what the universe seems built for, and humans are no exception. Your body feels stable because your brain creates continuity, but biologically and physically, you are changing every second. Cells die constantly. Molecules are replaced. Atoms move in and out of your body through breathing, eating, drinking, and waste. The version of you sitting here today is physically different from the version that existed years ago, yet somehow, despite all that replacement, you still feel like the same person. That feeling is one of the strangest things in existence. Physics can explain the particles inside your brain. It can explain electrical signals moving through neurons. It can explain chemical reactions, metabolism, heat, and energy transfer. But the actual experience of being you, the private awareness behind your eyes, remains deeply mysterious, and death attacks exactly that point. For thousands of years, humans imagined the self as something separate from the body, a soul, a spirit, some invisible essence that survives physical destruction. But modern neuroscience keeps finding stronger connections between consciousness and the physical brain itself. Damage a tiny part of the brain, and personality can change. Change the chemistry, and perception changes. Interrupt electrical activity with anesthesia, and consciousness disappears entirely for hours. Split certain neural connections, and awareness itself behaves differently. The more scientists studied the brain, the harder it became to treat consciousness as something independent from physical matter. That creates a terrifying possibility. The self may not be a thing. It may be a process, like a flame. A flame looks stable when you stare at it, but it only exists because fuel is continuously reacting in a precise way. Stop the process, and the flame is gone. The atoms remain. The energy transfers elsewhere. But the flame itself no longer exists. Physics increasingly treats human consciousness the same way, not as an object hidden somewhere inside the brain, but as an active pattern, maintained by constant physical activity. And patterns are fragile. This is where death becomes more disturbing than most people realise, because when humans imagine dying, they often picture darkness, silence, or floating awareness. But physics suggests something harder to emotionally process. The possible absence of experience altogether. Not eternal blackness, because blackness is still an experience, not silence. Silence is still something perceived by a mind. Physics raises the possibility that after death, there may simply be no subject left to experience anything at all. The reason this feels impossible to imagine is because the human brain cannot simulate non-existence. Every thought you have occurs from inside consciousness. Even imagining nothing still requires an observer imagining it. Your mind automatically inserts itself into every scenario. That limitation affects everyone. Even people who fully accept mortality often struggle to emotionally understand it. Intellectually, they know death is inevitable, but emotionally, the brain resists the idea that the stream of experience could completely stop. And yet, from a physical perspective, consciousness appears extremely dependent on matter arranged in a very specific way. A slight loss of oxygen can create confusion. A fever can distort reality. A small clot in the brain can erase language. Neurodegenerative diseases can slowly dismantle memory, identity, and personality while the body remains alive. That fragility matters because it suggests consciousness does not sit above physics. It emerges from it. And if consciousness is produced by physical processes, then death is not just the body failing. It is the collapse of the process itself. Some physicists and philosophers try to soften this conclusion by pointing out that matter and energy cannot truly be destroyed. The atoms in your body will continue existing. The energy disperses into the environment. In that sense, parts of you remain in the universe forever. But this is also where physics becomes emotionally cold, because survival of matter is not the same as survival of identity. If you burn a book, the atoms still exist afterward. The paper becomes ash, smoke, and heat. Nothing vanished from the universe, but the information, the story itself, may be permanently lost. That distinction between matter and information has become one of the most important ideas in modern physics. Increasingly, scientists think the real question about death is not whether atoms survive. Of course they do. The real question is whether the information pattern that created a conscious person can survive destruction. Right now, nobody knows. And that uncertainty sits at the centre of one of humanity's oldest fears. Because death is not just fear of pain. Most pain is temporary. Humans survive enormous suffering all the time. The deeper fear is annihilation. The possibility that everything you've ever seen, felt, remembered, loved, feared, or imagined depends entirely on a fragile biological structure that will eventually fail. Physics does not fully answer that fear, but it does something almost as unsettling. It shows that the universe may not contain anything designed to protect us from it. Right now, as you sit here, your body feels solid and personal. It feels like it belongs entirely to you. Physics says otherwise. Almost every atom in your body existed billions of years before you were born. The carbon in your muscles, the oxygen in your lungs, the calcium in your bones, and the iron in your blood all came from ancient stars that died long before Earth even existed. That is not poetry. It is literally how the universe works. In the early universe, right after the Big Bang, there were mostly simple elements, hydrogen and helium. That was it. The heavier elements needed for planets and life did not exist yet. Stars had to manufacture them through nuclear fusion over millions or billions of years. Inside stars, hydrogen atoms fused into helium. Larger stars kept going further, building carbon, oxygen, silicon, magnesium, and eventually iron. But creating the heaviest elements required something even more violent, stellar death itself. When massive stars exploded as supernovas, they blasted those newly formed elements across space. Entire future solar systems were seeded by the debris of dead stars, including ours. Every human being is physically connected to those explosions. The iron carrying oxygen through your bloodstream was forged inside a star that no longer exists. Some atoms inside your body may have travelled through multiple stars before becoming part of Earth, and the cycle never stopped. The air you breathe was breathed by other humans, animals, and ancient organisms long before you arrived. Water molecules move endlessly through oceans, clouds, rivers, plants, and living bodies. Atoms constantly exchange between people and the environment. In a very literal sense, your body is not a fixed object. It is a temporary gathering. That idea becomes even stranger when you look closer at biology. Most atoms in your body are replaced over time. Your skin regenerates, cells die and are replaced. The lining of your stomach renews rapidly. Even bone tissue slowly rebuilds itself. Some neurons can survive for decades, but many structures inside them still exchange material continuously. Physically, you are more like a whirlpool than a statue. A whirlpool looks stable, but the water inside it is constantly changing. The pattern remains recognizable, while the actual material flows through it. Human life works in a surprisingly similar way. Matter moves through the system, yet the person appears continuous. That raises a difficult question. If the atoms are constantly changing, then what exactly makes you you? Clearly, it is not the individual particles themselves. The atoms inside your brain today are not all the same ones you had years ago, yet your memories and identity appear connected across time. Physics points toward an uncomfortable answer. Identity may depend less on matter and more on organisation. The arrangement of matters. A pile of carbon atoms is not conscious. Rearrange those atoms into neurons, connected in extremely specific ways, powered by electrical and chemical activity. And suddenly there is awareness, memory, emotion, and subjective experience. This distinction between matter and pattern becomes extremely important when talking about death, because physics has no problem preserving atoms. The universe is very good at recycling matter, but preserving a conscious pattern is another issue entirely. Imagine taking apart a watch. All the pieces still exist afterward. Nothing disappeared, but the function of the watch is gone because the organisation was destroyed. You could scatter the pieces across a table, and every atom would remain physically real, yet time would no longer be measured. The human brain may work similarly. At death, the atoms remain, but the precise arrangement responsible for consciousness begins to collapse. Electrical activity stops, chemical gradients disappear, neural structures decay. The organised process that generated a conscious mind may vanish even while the matter survives. That is one of the hardest ideas in physics to emotionally accept, because humans naturally attach importance to material survival. We find comfort in the idea that part of us remains in nature. And in a physical sense, that is true. The atoms in your body will continue existing long after your death. Some may become part of plants, animals, oceans, or future humans. But physics forces a distinction between continuity of matter and continuity of self. And those are not necessarily the same thing. This is why many physicists describe humans as temporary, low-entropy structures. For a brief period, matter becomes organised enough to resist chaos and maintain awareness. Life holds itself together against constant disorder, using energy from food, sunlight, and metabolism. But the organisation is never permanent. Eventually, every biological system loses stability. Damage accumulates faster than repair, cells malfunction, DNA mutates, energy systems fail, entropy wins, and when the organisation breaks down far enough, the conscious pattern may disappear permanently. The terrifying part is how ordinary this process is from the universe's perspective. Stars explode, galaxies merge, species vanish, planets form and die. Matter rearranges endlessly across cosmic time. Physics does not divide reality into living and non-living in the emotional way humans do. It only describes changing configurations of energy and matter, which means your existence may be both incredibly special and physically temporary at the same time. A conscious human being is one of the most complex structures known in the universe. Yet according to physics, that complexity emerged naturally from particles following basic laws over billions of years. And one day those same laws will dismantle it again. If physics had a main antagonist, it would probably be entropy. Not gravity, not black holes, not radiation, entropy. Most people hear the word and think it simply means disorder, but the real idea is deeper and much more unsettling. Entropy is the tendency for energy to spread out and for organised systems to become less organised over time. It is built into the fundamental behaviour of the universe, and according to physics, every living thing is fighting a losing battle against it from the moment it is born. The second law of thermodynamics describes this process. In simple terms, it says that in a closed system, entropy tends to increase over time. Order naturally breaks down unless energy is constantly used to maintain it. That rule affects everything. A hot cup of coffee cools down, metal rusts, buildings decay, memories fade, stars burn through their fuel. Nothing stays organised forever without continuous energy and repair. Life exists because it temporarily pushes against this trend. Your body is constantly preventing itself from falling apart. Cells repair damage. Proteins fold into precise shapes. DNA copies itself. Your brain maintains electrical patterns and chemical balances every second of your life, even while sleeping. Your body is performing enormous amounts of maintenance just to remain alive. This takes energy constantly. Stop eating, and the system weakens. Stop breathing, and oxygen disappears. Stop circulation, and cells begin failing within minutes. The body is less like a permanent structure, and more like an active process, holding back collapse. That is why aging is so difficult to fully stop. Every time your cells divide, tiny errors accumulate. Radiation damages DNA. Proteins misfold. Waste products build up. Repair systems become less efficient. The body can fix enormous amounts of damage, but never perfectly. Over decades, entropy slowly gains ground. Aging, from a physics perspective, may simply be the visible effect of increasing disorder inside an extremely complex biological system. This changes how death looks scientifically. Death is not a magical event where something suddenly leaves the body. It is the point where the body can no longer maintain the organised processes required for life and consciousness. The fight against entropy fails, and once it fails far enough, the collapse accelerates. The heart stops circulating oxygen. Cells lose access to energy. Chemical balances disappear. Brain activity destabilises. Structures that required constant maintenance begin breaking apart. The organised pattern sustaining a living human starts dissolving back into less organised matter. The terrifying part is that entropy is not considered an accident or a flaw in physics. It appears to be one of the core rules of reality. Even more disturbing, entropy may explain why time itself feels like it moves forward. At the microscopic level, many physical laws work almost the same, whether time moves forward or backward. But entropy introduces direction. As shattered glass naturally spreads into scattered fragments, the fragments do not spontaneously reassemble into a perfect glass. Smoke disperses through air. It does not gather itself back into a cigarette. Entropy creates irreversibility. That irreversibility may define the entire human experience of time. You remember the past because information from lower entropy states remains recorded in your brain. You do not remember the future because those higher entropy states have not happened yet. Some physicists argue that what we call the flow of time may actually emerge from entropy increasing, which means your entire life is moving in one direction, because the universe itself moves toward greater disorder. And this does not stop with humans. The universe as a whole appears to be following the same path. Right now, stars create pockets of order by producing energy through fusion. That energy powers planets and makes life possible. But stars are temporary. One day, star formation will slow down permanently. Existing stars will burn out. Galaxies will grow darker. Over unimaginable stretches of time, the universe may approach what physicists call heat death. This is one of the bleakest concepts in cosmology. Heat death does not mean fire or explosions. It means equilibrium. Energy becomes so evenly spread out that no useful work can occur anymore. No stars, no sunlight, no metabolism, no organised systems extracting energy to maintain complexity. Just an enormous cold universe drifting toward maximum entropy. Even black holes, which seem eternal, are predicted to evaporate incredibly slowly through Hawking radiation. Given enough time, almost everything may dissolve into thin distributions of particles and radiation. From this perspective, life is astonishingly temporary. For a brief moment, matter organises itself into living structures capable of thought and awareness. Humans fall in love, build civilizations, create music, invent mathematics, explore space, and ask questions about existence itself. But all of it happens during a narrow window where entropy has not fully won yet. The realization can feel horrifying because it strips away the idea that stability is normal. Physics suggests instability is normal. Temporary order is the rare exception. And yet there is another side to this. Entropy is also the reason complex life became possible in the first place. Without energy differences, stars would never shine. Without stars, chemistry would remain simple. Without thermodynamic imbalance, no biological systems could exist. Life survives by feeding on gradients and delaying equilibrium. In other words, humans exist because the universe is not dead yet. But according to physics, the universe is slowly heading there. Most people instinctively imagine a brain as a storage device. Your memories are kept somewhere inside it. Your personality lives there. Your consciousness sits inside your head, like a passenger inside a machine. But modern neuroscience paints a stranger picture. The brain is less like a container and more like an event. Everything you experience right now, your thoughts, emotions, vision, memories, identity, and awareness, depends on continuous electrical and chemical activity happening across billions of neurons. The process never stops while you're conscious. Your sense of self exists because enormous networks inside the brain are constantly communicating in precise patterns. If those patterns stop, the experience stops. That sounds obvious at first, but the implications are disturbing. A neuron is not intelligent by itself. It is just a biological cell capable of sending electrical signals. But the human brain contains roughly 86 billion neurons, connected through trillions of synapses. Tiny electrical pulses move through these networks constantly, creating patterns so complex that they generate perception, language, emotion, imagination, and self-awareness. What we call you may emerge from that activity, and the evidence for this connection is overwhelming. Change the brain, and the mind changes. A small tumour can alter behaviour completely. Damage to the frontal lobe can transform personality. Certain strokes erase the ability to recognise faces while leaving other functions intact. Neurodegenerative diseases like Alzheimer's slowly dismantle memory and identity piece by piece. Even chemicals can dramatically reshape consciousness. Alcohol, antidepressants, psychedelics, anesthesia, and sedatives all modify physical brain activity, and subjective experience changes immediately alongside it. That relationship matters because it suggests consciousness is deeply dependent on physical processes, not separate from them. Anesthesia is especially unsettling when you think about it carefully. Every day, millions of people undergo surgery. A doctor administers chemicals that disrupt communication between certain brain regions, and consciousness vanishes. Not sleep, not dreaming. Often there is simply nothing. One moment, awareness exists, and the next moment, the patient wakes up hours later with no sense of time passing. That gap is terrifying because it reveals how fragile conscious experience may be. A slight alteration in neural activity can completely interrupt the feeling of being alive and aware. Then there are seizures. During some epileptic events, synchronized electrical storms spread through the brain, temporarily disrupting normal processing. Consciousness can distort, fragment, or disappear entirely. People may lose awareness for seconds or minutes without any memory afterward. Again, the pattern changes and the self changes with it. This has pushed many scientists toward a difficult conclusion. Consciousness may not be a permanent entity hidden inside the brain. It may be a process generated by active information flow, like music. A song does not physically exist inside a speaker. The speaker only produces organized vibrations in real time. Stop the process, and the music disappears instantly. The components remain, but the experience is gone. The brain may operate similarly. The neurons are not the mind by themselves. Consciousness may emerge only when activity flows through the system in specific ways. That would explain why awareness can disappear during deep anesthesia, severe trauma, or death. The physical structure may still exist temporarily, but the process has stopped. And this creates one of the darkest questions in physics and neuroscience. If consciousness is an active process rather than a stored object, can it survive interruption? Right now, science has no evidence that it can. When the brain loses oxygen after cardiac arrest, neural activity begins failing rapidly. Within seconds, consciousness disappears. Within minutes, widespread cellular damage begins. Electrical patterns destabilize. Connections break down. If circulation is not restored quickly, the organized activity required for awareness may become impossible to recover. This is why many researchers think death is fundamentally tied to information loss. The terrifying possibility is not simply that the body stops working. It is that the specific dynamic pattern producing subjective experience dissolves permanently. And unlike organs or bones, patterns are hard to rebuild. Once destroyed, you can replace atoms in the brain over time while maintaining continuity because the overall organization remains active. But if the organization fully collapses, restoring the exact conscious process may be impossible. This becomes even stranger when you consider a memory. People often imagine memories as fixed recordings, stored somewhere inside the brain. But memories are not static files. Every time you remember something, the brain partially reconstructs it. Memories change over time. They can distort, weaken, merge, or even become completely false. Your identity is more fluid than it feels. The self you experience may actually be a continuously updated model generated by the brain. Neuroscience increasingly suggests that the brain constantly integrates sensory input, memories, emotions, and predictions into a unified experience we call consciousness. But there may not be a single central location where you exist. No scientist has found a specific spot in the brain where awareness sits like a tiny observer. Instead, consciousness appears distributed across interacting systems. The self may be more like a coordinated process than an object. And if that is true, death becomes harder to emotionally understand, because people naturally want to believe there is some core essence untouched by physical damage, something permanent underneath the biology. Physics and neuroscience have not found that thing. Instead, they keep finding processes, networks, electrical patterns, and fragile systems dependent on energy flow and physical stability, which means the conscious person reading this right now may be less like a soul inhabiting matter and more like a temporary pattern matter is performing. Most people think death is a single moment. 1 second you're alive, the next second you're gone. But medicine and physics do not really describe death that way anymore. As science advanced, researchers realized death is not an instant event. It is a process. And depending on how you define it, humans may actually experience multiple kinds of death. The first is clinical death. This is the stage most people traditionally associate with dying. The heart stops beating, breathing stops, blood circulation ends, oxygen no longer reaches the brain and organs. For most of human history, clinical death was considered final. Once the heartbeat disappeared, the person was declared dead. But modern medicine changed that assumption. Today, people can sometimes be revived, minutes after clinical death, through CPR, defibrillation, advanced life support, hypothermia treatments, and emergency interventions. In rare cases, individuals have recovered after surprisingly long periods without a heartbeat, especially when low temperatures slowed cellular damage. That discovery completely changed humanity's understanding of death. It revealed something unsettling. The border between life and death is not as sharp as people once believed. Your heart stopping does not necessarily mean you are permanently gone yet. The second stage is biological death. This happens when cells and tissues become too damaged to recover. Without oxygen and energy, biological systems begin failing rapidly. Brain cells are especially vulnerable. Within minutes of oxygen deprivation, neurons start suffering irreversible injury. Chemical balances collapse. Cell membranes break apart. Structures decay. Eventually, the damage becomes too extensive for the organism to function again. At this point, current medicine cannot restore the body. The physical systems required for life have deteriorated beyond repair. But even biological death may not happen all at once. Different cells die at different rates. Some tissues remain alive temporarily after circulation stops. Hair and nails do not truly keep growing, but skin dehydration can create that illusion. Certain genes may even remain active for hours after death. The body shuts down in stages. This gradual collapse creates strange ethical and scientific questions. When exactly is the person gone? Not the body, the person. Because biologically, parts of the body may still function for a while after consciousness disappears completely. That leads to the third and perhaps most disturbing category: information theoretic death. This concept comes from physics, neuroscience, and information theory. It asks a deeper question than whether cells are alive. It asks whether the information that made a person who they were can still, even in principle, be recovered. That includes memories, personality, neural connections, learned experiences, emotional patterns, and the dynamic organization of the brain. If that information remains physically preserved, somehow future technology might theoretically reconstruct aspects of the person. But if the information is destroyed beyond recovery, then the individual may be permanently gone. This idea changes the meaning of death entirely. For example, imagine someone falls into freezing water and enters cardiac arrest. Their heart stops. Brain activity becomes extremely weak. By older definitions, they might appear dead, but because cold temperatures slow entropy and cellular decay, enough neural information may survive for doctors to revive them later. In that situation, clinical death occurred, but information theoretic death may not have. Cryonics is built around this distinction. Some people choose to have their bodies or brains preserved at extremely low temperatures immediately after legal death. The idea is not that they are secretly alive. The hope is that future technologies might someday repair cellular damage and recover the information encoded in the brain. Most scientists remain skeptical. Current cryonics cannot preserve the brain perfectly, and there's no proven method for restoring a preserved human consciousness. But the fact that serious researchers even debate this question shows how much the scientific definition of death has evolved. The real issue is no longer simply whether the heart beats. It is whether the informational structure of the mind survives destruction. And that introduces a terrifying possibility. A person could be biologically alive while major parts of their identity are gone. Advanced Alzheimer's disease already hints at this problem. A body can continue functioning while memory, personality, recognition, and communication slowly disappear. Families often describe the feeling that the person they knew vanished before the biological body died. From an information perspective, parts of the self may already be eroding long before physical death occurs. This forces science into deeply uncomfortable territory. What exactly are we trying to preserve when we try to preserve life? The heartbeat, the body, conscious awareness, memory continuity, identity. Physics offers no clear emotional answer because physics does not naturally deal in concepts like personhood. It deals in systems, patterns, structures, and information. And according to modern science, the human self may depend entirely on one extremely delicate informational arrangement inside the brain. That arrangement can survive temporary interruption under certain conditions. It can sometimes recover after trauma. It can even partially rebuild itself after injury. But there appears to be a limit. Once enough information is destroyed, the original conscious pattern may become unrecoverable forever. That may be the real point of no return. Not when the heart stops, not even when cells begin dying, but when the universe no longer contains enough surviving information to reconstruct the mind that once existed. Before Einstein, most people imagined time as universal. The universe had one giant clock ticking forward for everyone equally. A second on Earth was the same as a second anywhere else. Past, present, and future seemed obvious and absolute. Relativity destroyed that picture completely. According to Einstein's theories, time is not fixed. It changes depending on motion and gravity. Two people moving differently through space can experience time at different rates, and both perspectives can be correct at the same time. That sounds abstract until you realize it has been experimentally confirmed many times. Precise atomic clocks placed on airplanes tick slightly differently from clocks on Earth. Satellites in orbit experience time differently because they move quickly and exist in weaker gravity than the planet's surface. GPS systems must constantly correct for relativistic time distortion, or navigation errors would grow rapidly. Time literally flows differently depending on where you are and how fast you move. This already makes reality stranger than human intuition expects. But the truly disturbing part comes from how relativity treats the structure of time itself. In everyday life, the present feels uniquely real. The past seems gone. The future seems open and undecided. Consciousness appears to move through time, moment by moment, like a spotlight travelling forward. Relativity challenges that entire experience. One of Einstein's biggest discoveries was that there is no universal now. Events that appear simultaneous to one observer may happen at different times for another observer, moving differently through space. The order of events can depend on perspective. That means the universe cannot be cleanly divided into one shared present moment for everyone. This led many physicists and philosophers toward a radical interpretation called the block universe. In the block universe view, time may not flow at all. Instead, the entire history of the universe, past, present, and future, simply exists as one four-dimensional structure. Every event occupies its place in space-time, the same way every location occupies a position on a map. From that perspective, your birth, your current life, and your death may all exist equally. You only experience moments sequentially because consciousness moves through them in a limited way. This idea feels deeply unnatural because human brains evolved to perceive change and motion. We experience time as unfolding, but relativity suggests that this feeling may not reflect the underlying structure of reality. Einstein himself hinted at this after the death of his friend Michel Besso. In a letter to Besso's family, he wrote that for physicists who believe in relativity, the distinction between past, present, and future is only a stubbornly persistent illusion. That sentence unsettled many people because it changes what death could mean. If all moments in space-time remain equally real, then in some sense, every moment of your life continues to exist permanently within the structure of the universe. The child you once were is not erased. The conversations you had years ago are not destroyed by time moving forward. They still occupy their coordinates in space-time. But this creates both comfort and horror at the same time. Comfort, because it suggests existence is not simply erased into nothingness. Horror, because it may also mean your death already exists somewhere in space-time, just as permanently as your birth. In the block universe interpretation, the future may be as fixed as the past. That raises uncomfortable questions about free will. If space-time already contains all events, are your choices truly open, or are they simply parts of the structure you experience sequentially? Physicists still debate this intensely, but relativity undeniably weakens the intuitive idea that reality unfolds one fresh moment at a time. And there is another disturbing consequence. If consciousness depends on moving through moments sequentially, then death may represent the end of that sequence for a particular observer. The moments of your life still exist within space-time, but no new conscious experiences are added beyond a certain point. Imagine a film reel. Every frame exists physically at once. The characters inside the movie only experience events frame by frame, because that is how the sequence is structured. Relativity suggests reality may resemble this more than humans naturally assume. Your entire life could already be part of space-time as a complete structure. You experience it gradually because your consciousness is embedded inside it. This does not prove immortality. In fact, many physicists would argue it does the opposite. The block universe does not imply continued awareness after death. It only suggests that moments do not vanish in the way humans emotionally imagine. Your past still exists, but so does your ending. And perhaps the strangest part is that modern physics still cannot fully explain why conscious beings experience time moving forward at all. Some researchers suspect the sensation of flowing time emerges from entropy and memory formation, rather than from time itself physically moving. In other words, the brain may construct the feeling of now as it processes information. If that is true, then one of the most basic features of human existence, the sensation of time passing, may be partly generated inside the mind. Physics started by trying to explain motion and gravity. It ended up questioning whether the present moment even objectively exists. Black holes are probably the closest thing physics has to cosmic nightmares. They are regions of space-time where gravity becomes so intense that nothing escaping beyond a certain boundary, called the event horizon, can ever return. Not light, not matter, not information, at least according to the original understanding of black holes. And that last part created one of the biggest crises in modern physics. Because if information can truly disappear inside black holes, then some of the deepest laws of physics may be wrong. To understand why this became such a huge problem, you first have to understand how physics usually treats information. In modern science, information is not just words or computer data. Information means the complete physical description of a system, the exact arrangement of particles, energies, quantum states, and interactions. According to quantum mechanics, information should never be fundamentally destroyed. Physical systems can change form, spread out, or become impossibly scrambled, but the underlying information describing reality is expected to remain preserved. Black holes seem to violate that rule completely. Imagine throwing an object into a black hole, a chair, a book, a human body. From the outside, everything crossing the event horizon appears permanently lost. The object disappears from the observable universe. At first, physicists assumed the information was simply trapped inside forever. Then Stephen Hawking discovered something shocking in the 1970s. Black holes are not entirely black due to quantum effects near the event horizon. Black holes slowly emit tiny amounts of radiation, now called Hawking radiation. Over incredibly long periods of time, this radiation causes black holes to lose mass and eventually evaporate completely. And that created the paradox. If the black hole eventually disappears, what happens to all the information about the things that fell into it? If the information is gone forever, then quantum mechanics breaks. If the information somehow survives, physicists needed an explanation for how. This became known as the black hole information paradox, and it triggered decades of arguments between some of the world's greatest scientists. What made this issue so important is that it connected gravity quantum mechanics, entropy, and information all at once. It forced physicists to confront a disturbing possibility. Maybe information is more fundamental to reality than matter itself. Over time, many researchers began leaning toward the idea that information is never truly destroyed, even by black holes. But the proposed solutions became increasingly strange. One possibility is that information is somehow encoded on the surface of the event horizon itself. This idea contributed to the development of the holographic principle, which suggests that the information inside a region of space may actually be describable on its boundary. In simplified terms, some physicists believe our three-dimensional reality could behave similarly to a hologram generated from information stored on lower dimensional surfaces. That sounds like science fiction, but versions of this idea emerge from real attempts to solve black hole physics mathematically, and suddenly death started looking different through the lens of information theory. Because if the universe fundamentally preserves information, people naturally ask a dangerous question. Could information about a human consciousness also survive somehow? This is where many discussions become confused. Preservation of information does not automatically mean preservation of experience. That distinction matters enormously. Imagine burning a photograph and recording every particle interaction perfectly. In principle, the information describing the image might still exist somewhere within the smoke, heat, and rearranged atoms, but the photograph itself no longer functions as a photograph. Similarly, even if the universe preserves information about your brain at some deep physical level, that does not mean your conscious awareness continues. Physics may preserve traces without preserving subjective experience. And that is exactly what makes this topic unsettling. Because black holes forced physicists to think differently about what destruction even means. For centuries, humans imagined destruction as simple disappearance. But modern physics increasingly suggests that reality may transform and scramble information rather than erase it completely. The problem is that scrambled information can become effectively unrecoverable if you shred a book into microscopic pieces and scatter them across the ocean. The information technically still exists in the arrangement of particles, but reconstructing the original text becomes practically impossible. Death may work similarly. The informational pattern that created your consciousness could disperse into forms no longer capable of generating awareness. And black holes provide a terrifying cosmic version of that idea. Some physicists now think black holes may act less like destroyers and more like extreme information scramblers. Information falling inside becomes encoded in ways almost impossible to decode again. In recent years, debates about this paradox became even stranger. Some theories suggest black holes might contain firewalls at the event horizon. Others propose wormhole-like connections between quantum systems. There are even ideas linking quantum entanglement directly to space-time geometry itself. The deeper scientists investigate black holes, the more reality begins resembling something profoundly informational beneath the surface. But there is an emotional trap hidden here. Humans desperately want preservation of information to imply personal survival. Physics does not currently support that conclusion. Even if every particle interaction involving your brain leaves traces in the universe forever, the conscious process that experience being you may still end permanently when a brain's organization collapses. Black holes taught physicists that information may never fully vanish, but they also revealed something colder. The universe might preserve information without preserving the person. Physics can explain stars exploding billions of light years away. It can predict the behavior of subatomic particles with absurd precision. It can describe black holes, quantum fields, gravity, and the evolution of the universe itself. But there is one thing science still cannot fully explain. Why does any of this feel like something from the inside? Why is there subjective experience at all? You can describe the brain in extraordinary detail. Neurons fire, chemicals move across synapses, Electrical signals travel through networks. Information gets processed, stored, and integrated. Scientists can scan brain activity and correlate certain patterns with emotions, memories, decisions, and perception. But none of that fully explains consciousness itself. This problem is so difficult that philosophers gave it a name: the hard problem of consciousness. The easy problems involve explaining mechanisms. How does the brain recognize faces? How does memory work? How does the nervous system process pain? Those are difficult scientifically, but they are still problems about function. The hard problem asks something deeper. Why should physical processes produce experience at all? A computer can process information without feeling anything. A calculator performs operations without awareness. Even highly advanced AI systems can manipulate language and data without any proven inner experience. So why does a physical brain produce the feeling of being alive? Why is there an actual first-person perspective attached to matter, arranged in a certain way? Right now, nobody knows. And that uncertainty creates enormous tension in discussions about death, because if consciousness is fully explainable through known physics, then death may simply be the end of a biological process. But if consciousness depends on something science has not yet discovered, then our understanding of death could be incomplete. Some scientists believe consciousness is emergent. Emergence happens when simple parts interacting together create unexpected higher level behavior. A single water molecule is not a wave, but large numbers of molecules interacting can create tides, storms, and ocean currents. Similarly, individual neurons are not conscious by themselves, but massive networks of neurons interacting dynamically may generate awareness. This is currently the dominant scientific view. According to this idea, consciousness emerges naturally once information processing becomes sufficiently complex and integrated. No soul or hidden force is required. The brain creates subjective experience through physical activity alone. But critics argue that this explanation still leaves the deepest question unanswered. Even if complexity produces intelligent behavior, why should it produce experience? Why does processing information feel like something instead of nothing? Some researchers suspect modern physics may still be missing part of the picture. Not supernatural forces, not magic, but potentially deeper laws connected to information, quantum mechanics or space-time itself. A few scientists have proposed that consciousness could be a fundamental feature of reality, somewhat like mass or charge. Others explore ideas involving integrated information, where consciousness corresponds to the amount of interconnected information within a system. There are even fringe theories suggesting that consciousness may play a role in quantum measurement, though most physicists remain skeptical of these claims. The problem is that consciousness sits at an awkward boundary between objective science and subjective experience. Physics works by measuring external behavior. Consciousness is internal. You can study brain activity from the outside, but you cannot directly observe another person's subjective experience. You only infer it exists because other humans behave similarly to you. This creates strange philosophical possibilities. Could a system behave exactly like a conscious human without actually experiencing anything internally? Some philosophers call this a philosophical zombie, a being physically identical to a person, but completely lacking subjective awareness. It sounds bizarre, but the thought experiment exposes how difficult consciousness is to define scientifically. And this uncertainty makes death harder to interpret, because if scientists do not fully understand what consciousness is, they cannot completely explain what happens to it when the brain dies. At the same time, there is a danger here. Whenever science encounters something mysterious, humans tend to rush toward comforting explanations. Throughout history, gaps in knowledge often became places where people inserted supernatural ideas. Lightning was once explained through gods. Diseases were blamed on spirits. Mental illness was treated as possession. Now consciousness occupies a similar gap. The fact that science cannot fully explain awareness does not automatically mean consciousness survives death or exists independently from the brain. It only means the problem remains unsolved, and so far, every measurable aspect of consciousness still appears tightly connected to physical brain activity. Damage the brain, and consciousness changes. Interrupt neural communication, and awareness disappears. Alter chemistry, and subjective experience transforms. No experiment has demonstrated consciousness functioning independently of physical systems. That evidence matters because it suggests that whatever consciousness ultimately is, it may still depend heavily on organised matter and energy. And this creates a terrifying possibility. The greatest mystery in human existence may also be extremely fragile. Everything you love about being alive, emotion, memory, beauty, fear, curiosity, identity, could emerge from patterns inside a biological machine, vulnerable to injury, decay, and entropy. Physics has mapped galaxies and decoded atoms, but the one thing every human directly experiences, consciousness itself, remains partly unexplained. And until science understands what consciousness truly is, humanity cannot fully know what death actually takes away. Few areas of science have been misunderstood more than quantum mechanics. The moment people hear words like observer, uncertainty, or quantum, conversations about consciousness and the afterlife tend to explode into speculation. Suddenly, social media fills with claims that physics has proven souls exist, consciousness survives death, or the universe somehow needs the human mind to function. Most of those claims are either exaggerated or completely false, but the reason quantum mechanics became connected to death and immortality is understandable. Quantum physics already shattered common sense once before. Particles behave like waves. Objects can exist in multiple possible states before measurement. Entangled particles influence each other across enormous distances in ways that still feel deeply strange. So people naturally wondered whether consciousness itself might depend on quantum phenomena. One of the most famous attempts to connect consciousness and quantum mechanics came from physicist Roger Penrose and anesthesiologist Stuart Hameroff. Their theory, called OR, proposed that consciousness might emerge partly from quantum processes inside structures called microtubules within neurons. According to the idea, tiny quantum events inside brain cells could contribute to conscious awareness in ways standard neuroscience does not fully capture. The theory attracted attention, partly because Penrose was not an outsider. He is one of the most respected mathematical physicists alive, known for major work on black holes and general relativity. But OR also faced enormous criticism. The biggest problem is decoherence. Quantum states are extremely delicate. In laboratory conditions, physicists often need ultra-cold temperatures and carefully isolated systems to preserve quantum coherence for meaningful periods. The human brain is basically the opposite of that environment. It is warm, wet, noisy, and chemically chaotic. Many scientists argue that stable quantum states inside neurons would collapse almost instantly, long before they could meaningfully contribute to consciousness. The criticism remains one of the biggest obstacles for quantum consciousness theories. In recent years, some experimental findings involving quantum-like effects in biological systems revived limited interest in the topic. Researchers discovered that certain biological processes, such as photosynthesis and bird navigation, may involve quantum behavior under specific conditions. Some studies also suggested unusual vibrations or quantum-related activity inside microtubules, though the evidence remains highly debated and far from proving consciousness depends on quantum mechanics. And this is where the internet often goes completely off the rails. A small scientific discussion quickly becomes science proves the soul exists. That leap is enormous. Even if quantum processes contribute to consciousness someday, that would not automatically mean consciousness survives death. Quantum mechanics does not magically protect information from biological destruction. The brain still depends on physical structure, energy flow, and organization. When those systems collapse, the conscious process may still end. Another popular misunderstanding involves the observer effect. People sometimes claim that quantum mechanics proves consciousness creates reality because observation changes outcomes in quantum experiments. But in physics, observation does not necessarily mean a conscious human mind watching something. It usually means interaction with a measuring system or environment. Particles do not wait for human awareness to decide how to behave. Quantum mechanics is strange enough already, without adding mystical interpretations that the science itself does not require. Then there is quantum immortality. This idea comes from the many worlds interpretation of quantum mechanics, which suggests quantum events may branch into multiple possible outcomes across parallel realities. Some people interpreted this to mean consciousness could always continue in branches where survival occurs. For example, if someone faces a deadly event, there might theoretically be branches where they survive against the odds. According to the speculative argument, a person would only remain aware in branches where consciousness continues, creating a kind of subjective immortality. It sounds fascinating until you examine it carefully. First, many worlds itself is only one interpretation of quantum mechanics, not proven fact. Second, quantum immortality is highly speculative even within that interpretation. Most physicists do not consider it serious evidence for personal immortality, and emotionally, the idea becomes horrifying very quickly. If consciousness always followed survival branches, it could imply endless existence through increasingly improbable and potentially miserable states. Aging, disease, isolation, and suffering could continue indefinitely rather than ending naturally. The concept stops sounding comforting almost immediately. What makes quantum mechanics emotionally powerful is not that it proves immortality, it is that it exposes how incomplete human intuition really is. Reality at fundamental scales behaves in ways the brain never evolved to understand naturally. Probability, superposition, entanglement, and quantum fields all challenge everyday assumptions about matter and existence. That leaves room for imagination. But imagination is not evidence. Right now, there's no accepted scientific theory demonstrating that quantum mechanics allows consciousness to survive bodily death. No experiment has shown awareness existing independently from physical systems. No verified observation has proven a quantum afterlife. At the same time, physics also cannot fully explain consciousness yet. That unresolved gap creates tension. People who desperately want survival often overinterpret quantum mysteries as proof. Strict materialists sometimes dismiss unanswered questions too quickly. The truth is more uncomfortable than either extreme. Quantum mechanics revealed that reality is stranger than humans expected. But strange does not automatically mean comforting, and so far the weirdness of quantum physics has not rescued humanity from mortality. If anything, it has shown that the universe can behave in ways completely indifferent to what humans hope is true. Few subjects create more arguments between science and spirituality than near-death experiences. People who survive cardiac arrest, severe trauma, drowning, or other life-threatening events sometimes report remarkably vivid experiences. They describe tunnels of light, feelings of peace, seeing deceased relatives, floating above their bodies, or observing doctors working on them during resuscitation. For many people, these stories feel like direct evidence that consciousness survives death, but neuroscience offers another explanation. A dying brain does not simply switch off like a light bulb. Under extreme stress, oxygen deprivation, chemical imbalance, and failing neural activity can create intense and unusual experiences. Researchers studying near-death experiences, or NDAs, increasingly think many of these reports may emerge from the brain's final attempts to maintain coherent perception. during collapse. What makes this difficult is that the experiences often feel more real than ordinary life. Survivors frequently describe them as hyper-vivid, emotionally overwhelming, and unforgettable. Some even say the experience permanently removed their fear of death. That emotional intensity gives NDAs enormous psychological power, but powerful experiences are not automatically evidence of an afterlife. The brain is fully capable of generating realities that feel absolutely convincing. Dreams can feel real while they happen. Hallucinations can appear completely genuine. Psychedelic states can produce experiences people describe as more real than reality. The certainty of an experience does not guarantee its interpretation is correct. Scientists have identified several mechanisms that may contribute to near-death experiences. One major factor is oxygen deprivation, known as hypoxia. When the brain loses oxygen, visual processing can distort dramatically. Tunnel vision may occur because peripheral vision fails first, while central vision remains active longer. Bright lights, distortions, and unusual sensory effects can emerge during this process. Carbon dioxide buildup may also play a role. Some studies found elevated carbon dioxide levels in survivors who reported vivid near-death experiences. High CO2 levels can alter perception, emotion, and awareness significantly. Then there are neurotransmitters. Under extreme stress, the brain releases powerful chemicals that affect consciousness. Endorphins may reduce pain and create feelings of peace or detachment. Other compounds can distort time perception and memory formation. Some researchers suspect the brain may even release psychedelic-like chemicals under certain extreme conditions, though evidence remains limited and controversial. Electrical activity also becomes unstable during dying states. In some animal studies, researchers observed sudden bursts of synchronized brain activity shortly after cardiac arrest. These bursts briefly resembled patterns associated with conscious processing. Similar phenomena may occur in humans, potentially contributing to vivid experiences during the early stages of clinical death. This is important because people often imagine death as a smooth shutdown. In reality, the brain may enter chaotic and highly unusual states before activity fully ceases. Memory reconstruction complicates things further. Many near-death experiences are not reported during the event itself, but reconstructed afterward when consciousness returns. The brain naturally builds narratives to organize fragmented experiences, emotions, and perceptions. Cultural expectations, personal beliefs, and prior knowledge can shape how these experiences are interpreted and remembered. That helps explain why NDE reports vary across cultures. Certain themes appear repeatedly: light, separation from the body, altered time. But religious imagery often reflects the individual's background. A Christian, Hindu, or secular person may interpret similar neural experiences very differently. Still, some cases remain deeply unsettling, even to skeptics. There are reports of patients accurately recalling details from operating rooms while supposedly unconscious. Others describe experiences occurring during periods of severely reduced brain activity. These accounts continue fueling debate because consciousness itself remains poorly understood. But there is a crucial scientific point here. Poorly understood does not mean supernatural. The fact that science cannot yet explain every detail of near-death experiences does not automatically prove consciousness leaves the body or survives death independently. It simply means the brain, under extreme conditions, is extraordinarily complex, and complexity often feels mysterious. Physics itself cannot currently say much about subjective experiences during dying. Physics can describe energy transfer, neural activity, oxygen loss, entropy, and biological collapse. But it cannot directly measure what an experience feels like from the inside. That limitation leaves room for interpretation. Some people see NDAs as evidence that consciousness transcends the brain. Others see them as the predictable effects of a stressed nervous system approaching failure. Right now, there is no scientific consensus proving survival after death from near-death experiences alone, but there is something undeniably revealing about them. They expose how fragile the boundary between reality and perception truly is. Your sense of self, space, time, and existence depends on a biological system capable of generating entire worlds internally. Under normal conditions, that system aligns reasonably well with external reality. Under extreme stress, it can produce experiences that feel transcendent, eternal, or supernatural. And this leads to an uncomfortable possibility. Some of the most meaningful experiences humans report near death may originate not from escaping the brain, but from the brain desperately struggling not to disappear. For most of history, humans treated matter as the foundation of reality. Everything was about physical objects. Rocks, planets, bodies, atoms. Matter seemed primary, while information sounded abstract, something humans invented through language, books, and computers. Modern physics gradually changed that view. Today, many physicists think information may be one of the deepest layers of reality itself. That shift happened partly because of thermodynamics, quantum mechanics, and black hole research. Scientists realized that physical systems are not defined only by matter and energy, but also by how information is arranged inside them. Two objects can contain the same atoms and still be completely different because of informational structure. A living brain and a dead brain may contain nearly identical matter immediately after death. The difference is organization, electrical activity, neural connectivity, chemical balance, and dynamic information processing create the conscious system. When those patterns collapse, the matter remains, but the functioning mind disappears. This is why information theory became so important to discussions about death. From a physics perspective, identity may not depend mainly on the particles themselves. It may depend on the pattern those particles create. Think about music stored digitally. The song is not tied to one specific device. You can copy it between phones, hard drives, and servers. The physical hardware changes, but the informational pattern remains recognizable. Some scientists wonder whether consciousness works similarly, not necessarily in a mystical sense, but as a highly complex informational process implemented through physical matter. This idea becomes both fascinating and terrifying very quickly, because if your identity is fundamentally information, then in principle, it might someday be possible to reconstruct or copy that information. And that raises one of the darkest philosophical problems in modern science. Would the copy actually be you? Imagine future technology scans your brain perfectly. Every neuron, every synapse, every memory, every emotional pattern is mapped with total precision. Then an artificial version of your mind is recreated digitally or biologically somewhere else. The copy wakes up believing it is you. It remembers your childhood. It recognizes your family. It fears death. It continues conversations exactly where you left off. From the outside, the copy appears identical. But what happens to your original consciousness? This is where intuition breaks down completely. Most people instinctively assume continuity matters. If the original biological brain dies while the copy survives, many would argue the original person is still gone. The copy may behave identically, but the subjective experience attached to the original consciousness may have ended permanently. In other words, duplication may not equal survival. This problem appears in many famous thought experiments. The transporter paradox is one example. Imagine a machine that scans your body, destroys it, and reconstructs an identical version elsewhere using new atoms. Is the reconstructed person truly you, or just a perfect copy with your memories? From the outside, nobody could tell the difference, but subjectively, something horrifying may have happened. Your consciousness may have ended, while another version merely inherited your identity. Physics does not currently have a clear answer. because science still does not fully understand what creates continuity of conscious experience. This becomes even stranger when you realise your brain already changes continuously. Atoms are replaced over time. Neural connections shift, memories evolve, yet you still feel like the same person from year to year. So what exactly preserves identity? Some philosophers argue continuity is partly an illusion generated by memory and brain function. Others believe uninterrupted conscious experience is essential. Still others think identity may not have sharp boundaries at all. Physics offers no comforting certainty here. Instead, information theory pushes humanity toward a deeply unsettling possibility. The self may be reproducible without being preservable. And if that is true, immortality through copying may not actually save the original conscious observer. This idea also changes how we think about death itself. Traditionally, death meant destruction of matter, but increasingly scientists describe death as destruction of organised information. When a person dies, the atoms remain. What disappears is a specific informational arrangement capable of generating consciousness. And because information can theoretically exist in multiple forms, some researchers speculate that future civilizations might reconstruct human minds from surviving records, brain scans, DNA, or other physical traces. But again, reconstruction raises the continuity problem. Would a recreated version truly continue your subjective awareness, or would it simply be a new conscious being carrying your memories? That distinction may be impossible to test scientifically because consciousness is private. No experiment can directly compare two subjective experiences from the inside. This is one reason discussions about digital immortality often become emotionally disturbing instead of comforting. People imagine escaping death through technology, but the deeper you examine the idea, the more uncertain survival becomes. A perfect replica may preserve information while failing to preserve the original conscious perspective. And that leads to one of the coldest conclusions modern physics suggests. The universe may care far more about information patterns than individual identity. Patterns can repeat, information can transform, matter can recycle endlessly. But the feeling of being a specific conscious observer right now, this exact stream of awareness, may still be painfully fragile and potentially impossible to duplicate without losing the original self forever. The simulation hypothesis started as a philosophical thought experiment. Then it escaped into mainstream culture and became one of the strangest, serious discussions connected to physics, consciousness, and death. The basic idea is simple. If civilizations eventually become advanced enough, they might create simulations containing conscious beings. Those simulations could be so detailed that the beings inside them would believe their world is real. And if one civilization can create many simulations, then simulated realities could vastly outnumber base reality. Statistically, some philosophers argue that might make it more likely that we are inside a simulation rather than the original universe. At first, this sounds like modern science fiction dressed up as philosophy, but the idea gained attention partly because it does not directly violate known physics. Modern reality already appears surprisingly mathematical. Physical laws behave with extraordinary precision. Information theory plays an increasingly central role in physics. Some researchers even note that the universe has limits, resembling computational constraints, such as finite information density and maximum speeds, like the speed of light. That does not prove reality is simulated, but it keeps the conversation alive. And once people start thinking about existence as computational, death begins looking different. Because if consciousness is ultimately information running on some kind of substrate, then in principle, it could potentially be paused, copied, restored, or modified. Inside a simulation, death might not mean annihilation. It could resemble deleting a character, shutting down a process, or storing information elsewhere in the system. This is where the idea becomes emotionally seductive. For thousands of years, humans hoped some deeper reality existed beyond the visible world. The simulation hypothesis offers a technological version of that hope. Instead of gods and spirits, the hidden layer becomes programmers, higher civilizations, or computational systems. But there is a darker side to this idea that people often ignore. If reality is simulated, then everything humans consider meaningful could be contingent on systems beyond their control. Your memories, personality, relationships, and even physical laws might depend on external processes you cannot access or understand. Entire civilizations could theoretically be paused, copied, edited, or erased instantly. The possibility creates a different kind of existential fear, not fear of death alone, but fear that reality itself may lack authenticity. And there is another disturbing problem. Even if reality were simulated, that would not automatically protect consciousness from destruction. Characters inside a video game are not immortal because the game exists on hardware. Their existence still depends entirely on active processing and stored information. Delete the relevant data and the character disappears. Similarly, if conscious beings inside a simulation depend on informational patterns, then death could still mean irreversible loss. If those patterns are destroyed, the simulation idea changes the framework, but not necessarily the outcome. Some people also misunderstand the hypothesis as scientific evidence. It is not. There is currently no experimental proof that humanity lives inside a simulation. Certain proposed clues, pixel-like space-time structures, mathematical symmetries, or computational limits, all have alternative explanations within standard physics. Most physicists remain skeptical because the hypothesis is difficult to test directly. A theory that cannot produce clear, falsifiable predictions sits awkwardly between philosophy and science. Still, the simulation hypothesis reveals something important about modern thinking on death. As physics shifted toward information theory, humans began imagining existence itself informationally. Consciousness started looking less like mystical spirit and more like process, computation, and pattern. And once identity becomes informational, questions about copying, preservation, and simulation become unavoidable. Could consciousness run on non-biological systems? Could minds exist in virtual worlds? Could entire realities emerge from information processing? Science cannot fully answer these questions yet, but there is a hidden emotional reason why the simulation hypothesis became so popular. It softens oblivion. People fear death, partly because it feels final and absolute. The simulation idea introduces the possibility that death might simply be transition within a larger system. Maybe consciousness gets backed up. Maybe existence continues outside the simulation. Maybe reality has hidden layers humans cannot perceive. Even people who reject traditional religion sometimes find comfort in computational versions of transcendence. But physics itself remains brutally neutral here. Nothing about the simulation hypothesis currently demonstrates survival after death. Even in a simulated universe, consciousness could still depend entirely on active processes, vulnerable to termination. In fact, the simulation framework may make existence feel even more fragile. A biological universe at least follows stable physical laws. A simulated universe could theoretically change instantly if controlled externally. The reality humans trust might depend on systems completely beyond comprehension. And then there's the deepest fear underneath all of this. If reality can be simulated perfectly, how would anyone ever know what is ultimately real? Every perception, memory, and experience already arrives filtered through the brain. Humans never access reality directly. They only experience internal representations generated by nervous systems. The simulation hypothesis weaponizes that uncertainty. It suggests the universe humans spend their entire lives trying to understand may itself be an interface hiding something deeper, not because physics proved it, but because modern science increasingly revealed how limited human certainty actually is. And when certainty collapses, death becomes even harder to define. For most of history, immortality belonged to mythology. Now it is becoming a technology problem. Some scientists, futurists, and tech companies seriously discuss the possibility that one day humans could preserve consciousness digitally. The idea usually falls under terms like mind uploading, whole brain emulation, or digital immortality. At first it sounds impossible. The human brain contains around 86 billion neurons, connected through trillions of synapses. Every thought, memory, habit, emotional response, and personality trait emerges from staggeringly complex patterns of activity inside this network. But supporters of mind uploading argue that the brain is ultimately a physical system, obeying physical laws. If the structure and activity of that system could be mapped with enough precision, then in theory, its functions might be recreated computationally. In other words, a mind might be emulated the same way software runs on hardware. That idea no longer sits entirely in science fiction. Modern neuroscience can already map tiny regions of brain tissue in extraordinary detail. AI systems can imitate human speech, personality traits, and conversational styles with increasing realism. Researchers are developing brain-computer interfaces capable of decoding certain intentions, words, or sensory signals directly from neural activity. None of this comes close to full consciousness transfer yet, but it pushes the discussion into uncomfortable territory, because once a digital copy becomes realistic enough, humans may struggle to define the difference between simulation and personhood. Imagine a future system trained on everything about you: your voice recordings, your messages, your memories, your habits, detailed scans of your neural structure. The resulting AI behaves exactly like you. It remembers your childhood, tells your favourite jokes, recognises your family, and reacts emotionally in ways indistinguishable from the original. From the outside, it appears alive. Family members might speak to it the same way they once spoke to you. Future generations could interact with digital ancestors, reconstructed from preserved information. And this is where the nightmare begins. Because even if the copy is perfect, your original stream of consciousness may still end permanently. This is the copy problem. People often assume that if information survives, the self survives automatically. But continuity of information may not equal continuity of awareness. Imagine entering a machine that scans your brain perfectly and creates an exact digital version, while your biological body remains intact. Now there are two versions of you. Which one contains the original consciousness? From that moment onward, both versions begin having separate experiences. They diverge instantly. Each believes itself authentic, but they cannot both be the same continuous observer. That thought experiment reveals something deeply unsettling about identity. The feeling of being you may depend less on information alone and more on uninterrupted, subjective continuity. A copy may preserve personality without preserving the original conscious experience, and physics offers no obvious mechanism for transferring consciousness between substrates. This problem appears in teleportation thought experiments too. Suppose a futuristic transporter destroys your body while recreating an identical version elsewhere, atom by atom. Everyone outside the machine would think you survived. The recreated person would insist they are you. But from the inside, did your awareness continue, or did the original observer simply die, while a perfect duplicate inherited the memories? There may be no way to scientifically answer that question, because consciousness is fundamentally private, and that uncertainty makes digital immortality emotionally disturbing instead of comforting. Many futurists speak about uploading minds as if survival were guaranteed, but critics argue the process might create copies rather than preserve the original conscious self. In that scenario, digital immortality becomes a kind of replacement, not continuation, and yet humans may still pursue it aggressively, because even partial survival is psychologically tempting. a digital version of a loved one, could preserve conversations, personality, and emotional connection long after biological death. Entire identities might persist socially and culturally through AI systems trained on human lives. Some companies are already experimenting with primitive versions of this idea using chatbots modelled after deceased individuals. Right now, these systems are limited and often unsettling, but future versions may become nearly indistinguishable from real people in conversation. At that point, society faces difficult questions. Could a sufficiently advanced digital mind deserve rights? Could shutting it down count as killing? Could copies of one person exist simultaneously? Would identity become something humans duplicate endlessly? Physics itself does not forbid complex informational systems from existing on non-biological hardware. If consciousness emerges from information processing, then artificial consciousness may eventually become possible. But there is still no evidence that copying information transfers subjective awareness itself, and that distinction may define the entire future debate about death, because humans do not merely want their information preserved, they want to continue experiencing existence personally. They want to remain the observer behind their own eyes. Technology may eventually preserve behaviour, memory, and personality with astonishing accuracy. It may even create conscious systems modelled after human minds, but physics still cannot explain whether continuity of self can survive duplication, which means the dream of digital immortality may hide a terrifying possibility. You could build something that thinks it is you, while the real you still disappears forever. Humans often think about death as a personal problem, a biological problem, something connected to aging, disease, accidents, or the limits of the body. Physics reveals something much larger and far more unsettling. Death is woven into the universe itself. Everything humanity has ever known exists during a temporary era of cosmic activity. Stars shine, galaxies evolve, planets form, and life emerges because the universe is still young enough and energetic enough for complex structures to exist. But according to modern cosmology, this will not last forever. The universe appears to be moving slowly toward a state where complexity becomes impossible. This idea comes from thermodynamics, especially entropy. As discussed earlier, entropy tends to increase over time. Energy spreads out, organized systems break down, differences in temperature and structure slowly disappear. Life depends on those differences. Earth receives concentrated energy from the sun. Organisms use that energy to maintain order and resist entropy temporarily. But stars are finite. They burn fuel, and eventually they die. Right now, the universe still contains enormous amounts of usable energy. That is why stars continue forming and galaxies remain active. But over incredibly long timescales, the cosmos begins changing dramatically. First, star formation slows down. Galaxies gradually consume or lose the cold gas needed to create new stars. Existing stars continue aging. Massive stars explode as supernovas. Smaller stars like the Sun eventually expand into red giants before collapsing into white dwarfs. One day, no new stars may form at all. This future era is sometimes called the degenerate era. The bright universe humans know today disappears. Galaxies become darker and quieter. Most remaining objects are dead stellar remnants. White dwarfs, neutron stars, and black holes drifting through expanding space. Even then, the universe keeps evolving. Over unimaginable spans of time, gravitational interactions slowly destabilize galaxies. Stars may be ejected into intergalactic darkness. Some dead stellar remnants collide. Others decay gradually. If proton decay exists, something physicists still have not confirmed experimentally, then even ordinary matter may eventually disintegrate. Atoms themselves could slowly fall apart over periods vastly longer than the current age of the universe. And then there are black holes. For a long time, scientists thought black holes might survive forever, but Hawking radiation changed that picture. Black holes slowly lose energy over absurdly long timescales. A supermassive black hole could take longer than 10 to the power of 100 years to evaporate completely. That number is so enormous that human language barely handles it meaningfully. Yet even black holes may eventually disappear, and after that comes one of the bleakest predictions in all of physics: heat death. This does not mean explosions or cosmic destruction. It means the opposite. The universe reaches maximum entropy. Energy becomes distributed so evenly that no significant work can happen anymore. No stars shine, no planets remain habitable, no organised structures extract useful energy. The universe becomes cold, dark, thin, and almost perfectly uniform. From a thermodynamic perspective, this is equilibrium. From a human perspective, it resembles cosmic extinction. What makes this terrifying is not only the scale, but the indifference. The universe does not appear designed to preserve complexity forever. Galaxies, civilizations, life, memory, and consciousness may all represent temporary structures emerging briefly before entropy overwhelms them. Humanity often imagines itself standing at the center of existence. Cosmology says otherwise. Earth formed around 4.5 billion years ago. The observable universe is roughly 13.8 billion years old. The era where stars actively shine may last trillions of years more. But even that is tiny compared to the incomprehensible future stretching ahead. Most of cosmic history may occur after life becomes impossible. And this creates a strange emotional reversal. Humans fear personal death intensely because individual lives are short. But physics suggests the universe itself is mortal in a much larger sense. The stars, galaxies, and energy gradients making consciousness possible are temporary conditions. In a way, life exists during the universe's active phase, a brief period where complexity can flourish before thermodynamic equilibrium slowly takes over. Some physicists explore alternatives to heat death. There are speculative ideas involving cyclic universes, vacuum decay, quantum fluctuations, or unknown future physics. Cosmology remains incomplete, and major mysteries still exist around dark matter, dark energy, and quantum gravity. But none of the leading theories currently suggest eternal, stable complexity. The long-term future still appears profoundly hostile to organised existence. And this changes how death looks philosophically. Human mortality stops seeming like a local biological flaw. Instead, it becomes part of a universal process affecting everything from cells to stars to space-time itself. The same physical laws governing your body also govern galaxies. Entropy dismantles all organised systems eventually. Yet strangely, this also makes life feel more extraordinary. For a tiny fraction of cosmic time, matter became conscious enough to study the universe that created it. Humans emerged during a narrow window where stars still shine and energy still flows. The universe produced beings capable of understanding its future decay before that decay fully arrives. And there may be something haunting about that. The cosmos evolved, conscious observers, just long enough for them to realise nothing lasts forever. Humans experienced time as something obvious. You remember yesterday, you experienced today. Tomorrow has not happened yet. Time feels like a river carrying everything forward, whether you want it to or not. But modern physics increasingly suggests that this feeling may not reflect the deepest structure of reality. Some researchers now suspect time itself may not be fundamental. That sentence sounds almost impossible to process, because every human experience depends on time. Motion, memory, aging, causality, and death all seem built around it. Yet when physicists try combining quantum mechanics with gravity, time starts behaving strangely. In some equations describing the universe at its deepest levels, time almost disappears completely. One famous example appears in attempts at quantum gravity, where certain formulations describing the entire universe contain no obvious time variable at all. The equations work mathematically, but they do not describe a universe moving from past to future in the normal sense. This shocked physicists because it suggested time might emerge from something deeper rather than existing as a basic ingredient of reality. And one of the strongest candidates for that deeper layer is information. Entropy plays a major role here. Earlier, we discussed how entropy creates direction in physical processes. Broken glasses do not spontaneously reassemble. Heat spreads outward. Systems move from lower entropy to higher entropy states. Some scientists think this thermodynamic direction creates the experience of time itself. The brain stores memories of lower entropy states, which is why you remember the past rather than the future. Information accumulates asymmetrically. As entropy increases, records of earlier states remain, while future states remain undefined from the observer's perspective. In this view, the arrow of time emerges from information flow and thermodynamics. Time may not fundamentally move forward. Instead, conscious systems experience ordered sequences of information changes that create the sensation of temporal flow. This idea becomes deeply unsettling when connected to consciousness. Your experience of time depends heavily on how the brain processes information. Under certain conditions, time perception changes dramatically. Moments of danger can feel slowed down. Dreams distort temporal experience completely. Psychedelics alter the sense of duration and sequence. Neurological disorders can disrupt temporal awareness. Even ordinary life changes time subjectively. Childhood summers once felt endless. Years in adulthood can seem to disappear rapidly. This reveals something important. The human sense of flowing time is not perfectly objective. It is partly constructed by the brain. Physics may support that conclusion. Relativity already showed that time is not universal. Different observers experience time differently, depending on motion and gravity. The next step may be even stranger. What humans call time might emerge from relationships between information, entropy, and observation, rather than existing independently. Some physicists compare reality to a sequence of informational states, rather than a moving timeline. Imagine a flipbook. The motion appears continuous when pages are viewed sequentially, but the individual pages themselves are static. Similarly, the universe might consist of relationships between states, while consciousness experiences those states as flowing time. This idea radically changes how death looks. Humans normally imagine death as being cut off from future time. But if time itself is emergent or relational, then existence may not fit ordinary intuition at all. In some interpretations of physics, moments do not vanish into non-existence. They simply occupy different positions within the structure of reality. Your childhood still exists as part of space-time. Earlier moments are not destroyed because now moved past them, but your conscious experience remains local. You experience one sequence rather than all moments simultaneously, and this creates a disturbing tension. Physics increasingly weakens the idea of an objective, flowing present, yet human consciousness appears built entirely around sequential experience. Death may therefore represent not the destruction of moments themselves, but the end of a particular conscious trajectory through them. The moments remain. The observer stops progressing. Some researchers go even further and suggest space-time itself could emerge from deeper informational relationships, especially in theories connected to quantum entanglement. Certain approaches to quantum gravity hint that geometry and time may arise from networks of information at microscopic scales. If true, reality may be fundamentally informational, long before it becomes spatial or temporal. That possibility changes humanity's position in the universe dramatically. People naturally assume space and time are the stage where life happens. Physics increasingly hints they may instead be emergent properties arising from deeper rules humans barely understand. And once time loses its absolute status, death becomes harder to define cleanly. What does it mean for something to end if temporal flow itself may be partly constructed by observers? What does gone forever mean in a universe where past states remain embedded in space-time? Physics does not provide comforting answers here. even if all moments exist in some sense. That does not guarantee ongoing conscious awareness after death. Your earlier experiences may remain part of reality, while your future conscious trajectory still terminates permanently. But the emotional effect is powerful. Humans evolved to think in terms of moving through time toward inevitable disappearance. Physics increasingly suggests reality may not operate according to that intuitive picture at all. The terrifying part is not simply that death exists. It is that modern physics keeps undermining the basic assumptions humans use to understand existence in the first place. Time once seemed solid. Now even time itself may be something the universe only temporarily produces. Most people feel like they control their own decisions. You choose what to say. You decide where to go. You weigh options, think about consequences, and act intentionally. Free will feels immediate and undeniable because conscious experience is built around the sensation of choosing. Physics complicates that feeling dramatically. At the deepest level, your brain is made of particles obeying physical laws. Neurons fire because of electrical and chemical interactions. Brain activity follows chains of cause and effect, extending backward through genetics, environment, memory, and prior physical states. And that raises a disturbing question. If the universe follows physical laws consistently, where exactly does free will enter the system? Classical physics created the first version of this problem. In a fully deterministic universe, every event follows necessarily from previous conditions. If someone knew the exact position and motion of every particle, they could theoretically predict all future events perfectly, including human decisions. This idea became associated with the thought experiment known as Laplace's demon, an imaginary intelligence capable of calculating the entire future of the universe from present information. In that framework, your choices may feel free while actually being inevitable consequences of prior physical states. Many people hoped quantum mechanics rescued free will because quantum events involve probabilities and uncertainty rather than strict determinism. But randomness does not automatically create freedom. If your decisions were partly determined by random quantum fluctuations, that would not necessarily make them more yours. Randomness is not the same thing as conscious control. A choice caused by unpredictable particles is still not clearly an act of independent will. So physics leaves humans trapped between two uncomfortable possibilities. Either decisions are determined by prior causes, or they emerge partly from randomness. Neither you nor anyone else controls. Neither option matches the intuitive feeling of complete personal agency. Neuroscience deepens the problem further. Experiments have shown that measurable brain activity related to decisions can appear before people become consciously aware of choosing. In some studies, researchers detected predictive neural signals fractions of a second before subjects reported making conscious decisions. The findings remain debated and limited, but they suggest consciousness may not initiate actions as directly as humans assume. Instead, conscious awareness might partly observe and rationalize decisions emerging from unconscious brain processes already underway. That possibility feels deeply threatening because identity depends heavily on agency. Humans define themselves through choices: morality, responsibility, ambition, guilt, love, and purpose. All assume people possess meaningful control over their actions. If free will weakens, the emotional structure of human life changes with it, and this connects directly to death. People fear death partly because life feels uniquely personal. Your experiences seem authored by you. Your memories, decisions, and struggles feel connected to an independent self, moving through time intentionally. But physics increasingly treats humans as physical systems embedded within larger causal networks. Your genes shaped your brain before birth. Your environment shaped neural development. Experiences rewired connections. Chemicals influence mood and thought. Countless factors beyond conscious control moulded the person you became. Even your current thoughts arise from brain activity you did not consciously design. This does not necessarily mean humans are puppets with zero agency. Many philosophers defend compatibilism, the idea that meaningful free will can still exist within physical causation. According to this view, freedom means acting according to your own motivations and reasoning, even if those motivations arise from physical processes. In everyday life, that distinction matters socially and psychologically, but emotionally, many people still resist the idea that consciousness might not stand outside physics, directing events independently. The resistance is understandable. Without free will, death feels different. Mortality becomes less like a personal tragedy, interrupting autonomous existence, and more like a physical process, unfolding through matter, organised temporarily into conscious form. The self stops looking like a separate commander and starts resembling an emergent pattern produced by biology and environment. And there's another terrifying implication. If human behaviour arises from physical laws, then the line separating humans from machines may be thinner than people want to believe. A sufficiently advanced artificial system might eventually display reasoning, emotion, and behaviour indistinguishable from human decision-making. If both humans and machines operate through physical information processing, then consciousness itself may not occupy the special metaphysical category people once imagined. That possibility unsettles humans, because free will has long served as proof of uniqueness. Physics erodes that certainty. At the same time, human experience still undeniably feels real from the inside. You experience deliberation, conflict, intention, and responsibility directly. Even if consciousness emerges from physical systems, the subjective experience of agency remains central to how humans navigate reality. Science has not fully explained that experience yet, and perhaps it never will completely, but the overall direction of physics and neuroscience points toward a difficult conclusion. The universe may not contain a sharp boundary where humans step outside causality and become independent authors of reality. Instead, consciousness, identity, and decision-making may emerge from physical systems shaped by laws extending far beyond individual control, which means death may not simply end a freely chosen life story. It may end a temporary, causal process the universe was performing through you all along. Humans are one of the few species fully aware that they will die. That awareness changes everything. Animals avoid danger, feel pain, and fight to survive, but humans can imagine the future in detail. We know our bodies will fail someday. We know everyone we love will disappear eventually. We can picture funerals, aging, loss, and the end of our own consciousness, long before it happens. And the human brain does not handle that knowledge comfortably. Psychologists have spent decades studying how mortality shapes behaviour. One influential idea, called terror management theory, argues that much of human culture exists partly to protect people from the psychological horror of death awareness. Religion, nationalism, legacy, morality, status, art, family, and even ambition may help humans feel connected to something larger and more permanent than individual life. In other words, civilization itself may partly function as a defense against mortality. That sounds extreme until you look at human history. Nearly every culture ever studied developed some concept of existence beyond death. Ancient Egyptians built enormous tombs designed for the afterlife. Greeks imagined Hades. Hindus developed ideas about reincarnation. Christians, Muslims, Buddhists, and countless other traditions created frameworks where death was not final annihilation. The details vary dramatically, but the emotional function often overlaps. Humans want continuity. They want the self to matter beyond biological decay. And from an evolutionary perspective, this makes sense. A species capable of imagining total non-existence would experience enormous psychological stress. Belief systems reducing fear and increasing social cohesion may have offered survival advantages over time. Groups united by shared meaning and moral structures often cooperate more effectively than groups overwhelmed by existential despair. That does not automatically make religious beliefs false, but it does suggest humans may be naturally biased toward ideas that soften death psychologically. Physics complicates this deeply. Modern science increasingly describes humans as temporary biological systems emerging from physical processes. Consciousness appears tied closely to brain activity. Entropy dismantles organized systems eventually. The universe itself may not preserve complexity forever. None of this feels emotionally satisfying. Humans do not naturally crave annihilation. That is why symbolic immortality became so important, even outside religion. People seek permanence through children, achievements, reputation, creativity, and memory. Writers leave books, artists leave paintings, scientists leave discoveries, parents leave descendants, carrying parts of themselves, genetically and culturally. Even social media reflects this impulse. Humans constantly document their existence because people fear disappearing without a trace. At a deeper level, humans want evidence that their lives mattered, and physics offers an uncomfortable response. Matter persists, energy transforms, information may survive in fragmented forms, but none of that guarantees personal continuity of conscious experience. This tension between emotional need and scientific uncertainty creates enormous conflict. Some people reject scientific materialism entirely because they find oblivion intolerable. Others embrace strict physicalism and conclude humans must simply accept mortality honestly. Many exist somewhere in between, balancing scientific understanding with emotional or spiritual intuition. The problem is that human cognition itself may resist true acceptance of non-existence. Your brain models future scenarios constantly, but every scenario still contains an observer. Even imagining your own funeral places your perspective somewhere outside the event, watching it happen. Consciousness cannot easily simulate its own absence, because any simulation still requires awareness performing it. This creates a strange psychological asymmetry. Before birth, billions of years passed without your existence. Most people do not fear that period emotionally, but the possibility of post-death non-existence feels terrifying because it threatens an already established conscious identity. And so humans construct narratives. Some are religious, some philosophical, some technological, some scientific, but nearly all attempt to answer the same emotional problem. How does a self-aware organism continue living while knowing it will eventually disappear? Even secular worldviews often replace supernatural immortality with other forms of transcendence. Humanity itself becomes the enduring project. Knowledge survives, civilization progresses, conscious individuals contribute briefly to something larger than themselves. This can provide genuine meaning, but it does not fully erase the fear, because physics keeps pushing humans toward a difficult possibility. Consciousness may be local, temporary, and fragile. The universe may not owe awareness permanence, and yet humans continue searching for permanence anyway. That search reveals something profound about consciousness itself. People do not merely want survival because they fear pain. Many forms of death are physically painless. What humans truly fear is erasure, the possibility that every memory, relationship, thought, and feeling attached to a specific conscious observer could vanish completely. Religion answered that fear with eternity. Technology answers it with digital preservation. Philosophy answers it with meaning. Physics, so far, answers it with uncertainty. And perhaps that uncertainty is why humans keep inventing afterlives, generation after generation. Not because evidence conclusively proves them, but because self-aware beings may find it almost impossible to emotionally accept the alternative. Of all the possibilities surrounding death, one may disturb humans more than any other. Not punishment, not darkness, not isolation, oblivion, complete non-existence. The reason this possibility feels so horrifying is that the human brain cannot truly comprehend it. Every experience you have ever known happened from inside awareness. Even when you imagine emptiness, there is still a you standing in the emptiness observing it. But oblivion would not be like floating in darkness forever. Darkness is still an experience. Silence is still perceived by someone. Oblivion means the complete absence of a subject capable of experiencing anything at all. And physics increasingly suggests this may be possible. Modern neuroscience ties consciousness closely to physical brain activity. Damage the system enough, and awareness changes or disappears. Stop neural processes entirely, and no evidence currently shows consciousness continuing independently. From a scientific perspective, this points toward a deeply uncomfortable conclusion. The feeling of being you may depend entirely on the temporary operation of a biological structure. When the structure fails permanently, the conscious perspective may vanish with it. Humans instinctively resist this idea, partly because evolution trained organisms to avoid death at all costs. Fear of annihilation helps survival. But there is another reason too. Consciousness naturally experiences itself as central and continuous. Your awareness feels like the stable core around which reality exists. It is emotionally difficult to imagine the universe continuing normally without that perspective attached to it. Yet billions of conscious beings have already died, and the universe appears to continue indifferently. That indifference may be the most frightening part. Stars still shine, people still fall in love, cities continue functioning. Reality does not pause when individual awareness disappears. Physics treats conscious beings as local processes within a much larger system, and local processes can end. Philosophers have long debated whether oblivion should actually be feared. Some point out a strange symmetry. Before you were born, you did not exist for billions of years. Most people are not emotionally disturbed by the time before birth. So why fear the state after death? The argument sounds logical, but emotionally, it rarely works. Because once consciousness exists, it develops attachment. You accumulate memories, relationships, goals, fears, identity, and expectations about the future. Death threatens to erase all of it. The asymmetry comes from interruption. Before birth, there is no self to lose anything. After life begins, there is. This creates one of the deepest existential problems humans face. Consciousness may be the only thing directly experienced with absolute certainty. You can doubt external reality. Philosophically, you can question memory, perception, or physics itself. But subjective awareness remains immediate, and oblivion threatens the disappearance of that certainty entirely. Some thinkers argue oblivion would not actually be experienced as suffering, because there would be nobody left to suffer. In a purely logical sense, this is true. Non-existence contains no pain, regret, loneliness, or fear, because all experience stops. But humans fear it anyway because the mind anticipates its own erasure while still conscious. It is like standing at the edge of a cliff the brain cannot emotionally process, and physics offers very little comfort here. Matter survives, atoms recycle, energy transforms, but personal continuity remains unresolved. Some people try to soften oblivion through symbolic immortality. You live on through memories, family, influence, culture, or contributions to society. Others focus on the idea that every moment lived remains permanently part of space-time in some interpretations of physics. These ideas can provide meaning, but they do not fully solve the problem of subjective disappearance, because most humans do not merely want traces of themselves to continue. They want to continue experiencing existence personally. And this is where the silence in physics becomes important. Science can describe what happens to bodies after death. It can measure neural activity, entropy, and biological decay. But science still cannot fully explain why consciousness exists at all. That unresolved mystery leaves room for hope. But hope is not evidence. Right now, no accepted scientific framework demonstrates that conscious awareness survives complete brain destruction. The terrifying possibility remains that death may truly end the stream of subjective experience permanently, and humans may never emotionally adapt to that possibility completely, because consciousness evolved to preserve itself, not to accept extinction peacefully. Still, there is another side to this. Oblivion may also explain why life feels precious. If conscious experience is temporary and fragile, then every moment becomes rare in a cosmic sense. Every conversation, memory, emotion, and perception exists against overwhelming odds within a universe mostly hostile to life. The fear of oblivion comes partly from recognizing the value of awareness itself. You fear losing consciousness because consciousness is extraordinary, and perhaps that is the final emotional paradox hidden inside physics. The same science that makes oblivion conceivable also reveals how astonishing it is that anything was conscious long enough to fear oblivion in the first place. Humans fear death so instinctively that immortality often sounds like the obvious solution. If oblivion is terrifying, then endless existence must be comforting. But the deeper philosophers, physicists, and writers thought about eternity, the stranger and darker it started to look, because infinite existence may create its own kind of horror. Human psychology evolved around limits. Hunger ends after eating, stories end after conflict resolves, lives end after aging. Meaning itself often depends on scarcity and finiteness. Moments matter partly because they cannot last forever. Now imagine removing that limit completely. An endless conscious existence, stretching not for thousands or millions of years, but literally forever. No ending, no final rest, no escape from awareness itself. At first, the mind tries to romanticize this idea. You could learn endlessly, explore the universe, witness civilizations rise and fall, watch stars being born, experience infinite knowledge. But eventually, another question appears. What happens after unimaginable lengths of time? Human brains are not designed to emotionally process infinity. Even 1,000,000 years is almost incomprehensible. Eternity is worse. It is not merely a very long time. It is the absence of any final boundary whatsoever. And that creates strange psychological problems. Would memories remain meaningful after billions of years? Would identity survive endless change? Could consciousness endure infinite repetition without collapsing into boredom, detachment, or madness? Some philosophers argued that eternal life would eventually drain meaning from experience itself. If every opportunity exists infinitely, urgency disappears. If nothing can truly be lost forever, value changes. Mortality gives decisions weight because time is limited. Endless existence risks flattening experience into repetition. Physics intensifies this discomfort. The universe is not built for eternal biological life. Stars die, galaxies drift apart. Entropy increases. Eventually, usable energy may disappear almost completely. So, any realistic form of immortality would require radical technological survival or entirely new forms of consciousness. And those possibilities become unsettling quickly. Imagine digital immortality lasting trillions of years inside artificial systems long after stars vanish. Conscious beings might exist in dark computational structures, extracting tiny amounts of energy from an aging universe. At first that sounds advanced, then it starts sounding like imprisonment. What if consciousness cannot stop? What if awareness continues long after meaning, novelty, or connection fade away? Some cosmological theories accidentally create even stranger nightmares. Certain interpretations of infinite universes imply that given enough time, random fluctuations could recreate conscious observers repeatedly. In an eternal cosmos, versions of you might emerge again, by chance, somewhere in space-time. This idea leads to the concept of Boltzmann brains, self-aware entities randomly forming briefly from chaos due to statistical fluctuations. The implication is deeply disturbing. Consciousness itself might emerge temporarily and pointlessly inside an infinite universe, disconnected from coherent history or reality. Then there are cyclic universe theories. Some models speculate that the cosmos could repeatedly expand and collapse through endless cycles. Others suggest infinite multiverses containing every possible variation of events somewhere. These ideas raise terrifying questions about repetition. If existence continues infinitely, could experiences recur endlessly in altered forms? Would identities repeat? Would suffering repeat too? The ancient concept of eternal recurrence explored this long before modern physics. The idea was horrifying because it implied living the same life infinitely many times without escape. Even if modern cosmology does not literally predict this, the emotional fear remains powerful. Eternity can begin feeling claustrophobic instead of liberating. And perhaps the strangest part is that humans often want contradictory things simultaneously. People fear death because they fear losing existence, but they also fear endless existence because they fear becoming trapped inside it. Mortality creates pain because life ends. Immortality creates pain because life may never end. This paradox reveals something profound about consciousness. Humans do not merely want infinite duration. They want meaningful existence. And meaning may depend partly on limitation, change, and contrast. A song matters because it ends. A moment matters because it passes. A life matters because time is finite. Physics itself does not currently offer evidence for eternal personal consciousness. But thinking seriously about immortality reveals that endless existence may not automatically solve the existential problem humans imagine. In some scenarios, it could intensify it. And there is another issue. Identity may not survive eternity anyway. Over enough time, memories change, personalities evolve, and experiences accumulate endlessly. After millions or billions of years, would the resulting consciousness still meaningfully be you, or would continuity gradually dissolve into something entirely different? Even immortality may not preserve the self humans hope to save. This leads to a strange conclusion. Perhaps humans are trapped between two equally difficult realities: a finite existence that ends too soon, or an infinite existence that eventually loses the structure giving existence meaning at all. Physics does not resolve this tension, but it does reveal something uncomfortable. The human relationship with death may not simply be fear of ending. It may also be fear that no possible answer truly satisfies a conscious mind aware of infinity. After everything modern physics has discovered, relativity, quantum mechanics, entropy, black holes, neuroscience, and information theory, you might expect science to give a clear answer about death. It does not. What physics actually provides is something stranger, a picture of reality that is far more complex, less intuitive, and less emotionally comforting than humans once imagined. On one hand, science has dismantled many traditional assumptions. The universe does not appear centered around human beings. Consciousness seems deeply tied to physical brain activity. Time may not behave the way human intuition expects. Entropy gradually dismantles organized systems. Stars die, galaxies evolve. Even the cosmos itself may eventually drift toward thermodynamic exhaustion. From that perspective, death looks natural and unavoidable. A temporary biological process ends. The informational structure, maintaining consciousness, collapses. Matter returns to larger physical cycles. Nothing in known physics guarantees personal survival after that point. And yet, physics also refuses to reduce existence to something simple. The deeper scientists investigated reality, the stranger it became. Matter turned into quantum fields and probabilities. Space and time became flexible rather than absolute. Information emerged as a potentially fundamental feature of the universe. Black holes challenged assumptions about destruction itself. Consciousness remained stubbornly unexplained. Again and again, physics revealed that human intuition is not a reliable guide to reality. That uncertainty matters, because while science has found no evidence proving an afterlife, it also has not fully solved the mystery of consciousness. Humans still do not know why subjective experience exists at all. We do not know precisely how awareness emerges from matter. We do not know whether consciousness is entirely reducible to current physical theories, or whether deeper principles remain undiscovered. But uncertainty is not proof. That distinction is crucial. Throughout history, humans often fill gaps in knowledge with whatever explanation felt emotionally satisfying. Physics repeatedly punished that habit. The universe consistently turned out less centered on human expectations than people hoped. So intellectual honesty requires accepting two things simultaneously. First, modern science currently provides no verified evidence that individual consciousness survives complete brain destruction. Second, consciousness itself remains one of the deepest unsolved problems in existence. Both statements are true at the same time, and perhaps that tension is what makes death so psychologically difficult. Humans want certainty. They want either guaranteed continuation or guaranteed extinction. But physics leaves us in a strange middle ground, where reality appears mechanistic in many ways, while still containing profound mysteries at its foundation. Meanwhile, everyday life continues. People wake up, work, fall in love, build families, create art, argue about politics, laugh with friends, and plan for futures they know are temporary. Conscious beings continue living ordinary lives inside a universe that may ultimately erase every physical trace of them. That sounds depressing until you realize something important. Meaning does not necessarily require permanence. Physics never promised permanence anywhere. Stars are temporary. Species are temporary. Galaxies are temporary. Even stable atoms may not last forever, depending on the underlying laws of nature. Impermanence appears woven into reality itself, and yet temporary things can still matter intensely. A song matters even though it ends. A conversation matters even though memory fades. A human life can shape other lives long after it disappears physically. The universe may not preserve individual consciousness eternally, but it still produced consciousness capable of curiosity, love, creativity, and self-awareness, at least briefly. That alone is extraordinary. For billions of years, the universe contained only particles, stars, and chemical reactions. And somewhere, on a small planet orbiting an ordinary star, matter became organized enough to ask questions about its own mortality. Physics explains much of the mechanism behind that process, but the emotional meaning of it remains something science alone cannot fully answer. And maybe that is the final truth hidden underneath all of this. Physics does not tell humans what death should mean emotionally. It only describes what reality appears to do. Right now, reality suggests that consciousness is fragile, time is strange, identity may depend on information, and the universe itself is temporary. But reality also produced beings capable of understanding those facts while still choosing to live, create, connect, and search for meaning anyway. That may not be comforting, but it may be one of the most human responses possible in a universe that never promised comfort to begin with. Watch the next video